So good morning. My name is Friedrich Deimann, and I'm the founder of the company Greenboats. Today I will tell you a bit about the story behind Greenboats and about our experience with natural fiber reinforced composites. As a first impression, I show you, yeah, like a little video about our last project that we just like finished this year. So that is the day sailor we built. It's a 27-foot sailing boat, a classic design above the waterline, and a modern underwater ship. So it's designed by Judel and Frohlich, and that is the project we finished in this year. It's built in vacuum infusion with flex fiber as a fiber reinforcement, and plastic bottles or recycled plastic bottles as a core material. First, I just want to tell about the story behind Greenboats. It's like 25 years ago. My uncle took me on a sailing trip, and from that moment, I just really fell in love with boats, and I was just like very impressed about the three-dimensional shaped hulls, and from this moment, I knew I want to get to know how to build boats and what's to know everything about the materials. And 3 years later, I did my first refit project. It was like a little wooden boat, and unfortunately I couldn't start with the apprentice as a boat builder straight away. So first I had to finish school. Luckily when I was 18, I started my apprentice as a wooden boat builder, and the company where I was working for, they teach me how to build mahogany sailing boats from like mold glued mahogany veneers, and that was just an awesome material to work with, like a nice wood. And every boat we built was like a bit of artwork. That was my way I get to know the boat building industry. But actually, I realized very quickly that is not the common way to build boats, because there are not many people who want to afford to have like a wooden boat, because it's artwork, it's very expensive, and yeah, you need to handle all the maintenance afterwards as well. After my apprentice, I worked for a company who was like focused on composites, and for me that was like totally different materials. But I was very impressed about these materials because you are able to build like very lightweight, very they're totally free in shape, and the material are just like so strong and long lasting. So yeah, the only thing I just didn't like at all was the material itself. So when you work with glass fiber and carbon fibers, it's just like very itchy on your skin, and as well like very smelly materials because the resin systems are like all very toxic, and it's just not a lot of fun to work with that materials. So my next step was, after like 4 years building composite boats, was that I did a boat building master. So and therefore I was actually thinking about how I could like combine the best parts of this boat, both like ways to build boats, like the wooden boat building and the composite, because I thought, okay, you need a material that you can produce in the way you produce composite boats, but I actually wanted to work with natural materials. So I started to do a lot of research, and yeah, that so I was searching about an alternative for the glass fiber reinforcements, and I found the flex fiber. So the flex fiber is a very light fiber, halfway of a glass fiber, and you end up pretty much with the same strength, and it's a material that you can produce in the same way. You can just mold it, you can do it in vacuum infusion, and all the building ways you know from the composite industries. And as well, it's a material where you can work very nicely with, because there are a lot of cloth or jackets or something that are made from linen fiber. So it's not a harmful material and not a synthetic material. And the other thing, it's as well like a lot better for the environment, because for producing glass fiber you need 5 times as much energy than for like just growing a natural fiber on an acre. And for carbon fiber, as example, you need 20 times as much energy for the producing. So I found this equivalent for the glass fiber. Next step, I was searching for a core material. So because all the normal core materials are all like petrochemical based, and just not a nice material first to work with, and not a nice material for the environment. So I found the cork as a core material. Cork has like really nice, very nice. It's very nice in insulation, in vibration absorption, and it's an hydrophobic material, and you can produce this as well like very nicely in the negative mold, and it's a recycled cork material. You can get it like in panels, like as you know from the foam materials, and it's very like a rough material. It's lightweight, and if maybe you have a damage or something like that, it's not taking any water. So the next step actually was to find a resin system that's not only petrochemical based. And yeah, I did a lot of testings with the different resin systems, and I found actually, like, for the masterpiece, it was like the hardest part to find a working system. Like, it's, yeah, like 9 years ago, and there wasn't like a lot of systems on the market. So yeah, the only thing I found was it was a epoxy that was not like entirely made from petrochemical. So it was based on linseed oil, and you got still petrochemical hardener, but it was like around 60% bio-based. And the other important things, you want to to have a long-lasting material as well, and therefore you still need petrochemicals in the resin systems. There are actually resin systems. They are 100% bio-based, but they won't last as long, and they are not as strong as the normal epoxy resins or the green epoxy resins. So, yeah, now a little video.
When we test materials such as flax, hemp, or kenaf for bending, we find that in terms of density, they have better characteristics than fiberglass composites when it comes to deformation or load bearing.
So luckily we have a very close cooperation with the University of Bremen, because yeah, we need to test our materials, and to build like an 8-meter sailing boat, you really need to know more about your materials. You can't just build. You need to know yeah, how you have to put the fibers in which areas. So you really need a laminate plan. So we, like, for the day sail as example, we got all this yeah, specific data from our Composites, and we went to Udall and Frohlich as an engineer, and they did all the calculations for our laminate planes, so that we really could, yeah, produce this boat as on a like really on a limit of weight. The whole day sailor has a weight from about like 1,200 kilogram. That's pretty light for an 8-meter 20 sailing boat. Yeah, after yeah, my boat building master, there is a bit of a gap between like my masterpiece and building the day sailor Flux 27. So we started with a lot of different projects. We built like the bicycle, a kiteboard, a longboard, a little motorboat, and some other project, a little sailing skiff. And our breakthrough was actually to get this big step from like building a canoe, building building like a little sailing dinghy and stuff like that, to yeah, building the Green Banter 2024. So we really had to go this step, because I think it's easy to understand that you can build like from a flax fiber a kiteboard, or like a small part like that, but to imagine that you are really possible to build a sailing boats where like 1.80 meter below the boat is like a keel with 500 kilo of plump, and on top there's like a 12-meter mast with Janaka was like 65 square meter, and to imagine that works with natural fiber, you really have to show it, because otherwise no one will believe. And yeah, we did that step, and it was a nightmare. It was like a lot of work with no money at all. Very less sleep. We slept in the shed, and we really had to build the boat. Like, I had like a team of just a lot of friends of mine. They were not boat builders in profession. They just like were helping us. But yeah, we realized that, and we had just the problem that we didn't have any money. So we needed to get sponsors, and we really needed to get this boat finished. And we got some sponsors. They gave us like materials and stuff like that, but still we didn't have enough money to finish the boat. So we actually went to the boat show in Düsseldorf. That was like very close. We started building the boat in 2015, and in January, it was in October 2015, and in January we had to actually to finish the boat, to present it on the boat show, and to sell the boat, because on some companies we just organized to get like a really long payment term, and so we had the risk just to lose everything. But luckily, we can see it on this picture. We didn't finish the boat, but we bring it to the boat show. We just had a really nice fiber optic, and we opened the boat, because it wasn't finished, so that you can get an impression of the material and of our artwork, and we sold the boat, like unfinished, the first boat from natural fiber reinforced composites. And then we finished this like 5 months later. It was totally finished, and it was closed, because there's one thing is we had this tiny little boat shed, and that was our start, and as well our breakthrough just to go this way. And after that night more, we just won a lot of prizes. We won the Ocean Tribute Award from the Prince Albert of Monaco Foundation, and the Bio-Composite Award, and award in Bremen, and that was for us exactly the right thing on the right timing. And then we did the next step, just to get a nice workshop where we where we are like able to continue projects like that, because in the shed before it was like you couldn't like have a crane. We didn't have a forklift. We had just nothing, just manpower. So that was the next step, and it was exactly the right step. In that shed, we are now like possible to continue with our boat building, and to continue with our like very nice artwork projects. Yeah, so a couple of pictures of the day sailor, and right now we are actually changed a bit. We are not a production company. We are doing a lot of prototyping, and actually our vision is to realize more projects, or to help other companies to get to know with natural fibers, fiber reinforced composites, and that are like different projects. We're building like a pickup truck for a company. We build this benches for a city in Germany. Yeah, that one is a nacelle project, like for the windmill industry. Down there, it's a sleeping tube for a company, and foiling kiteboard and stuff like that. So we are not the company who is like producing all the stuff, but we are helping other companies to get to know these materials, and to get a nice setup to be able to do products with natural fiber reinforced composites. So the other thing what we are just doing is you really need data about what you're doing, and to decide if it makes sense to change to another core material, or to change to a different fiber. We really do this LCA projects, so you have a real based data for decision making. Yeah, and it's very nice to see that the biocomposites are like more common, and companies like Baltic are really doing as well, like interior parts from natural fiber reinforced composites. So yeah, it's the future.
1, 2, 3, 4.
Yeah. So thank you, and now we have like time for questions. Yeah.
Is there any advantage in recycling those materials compared to traditional petrol-based resins?
That's actually one still a big problem, because you want to have a long-lasting product, and we say, okay, we have like this massive step that we have a material that is like to 80% bio-based, and it takes CO2 by the plant growing. So we have a material that's like 80% CO2 neutral, like pretty much like a piece of wood. So we have the option to burn the material like entirely, that we can't do with glass and carbon fibers. So that is actually a big step. But we still have a very long-lasting product, and but that's actually something that we want as well. Like that is, yeah.
So I can burn it in the oven, or do I need to have special devices for that?
Yeah, you need to have special devices actually. Yeah.
Thank you.
Hi, thank you. Can you maybe explain a little bit more on what it means to design with these materials, these natural materials?
It's actually, yeah, pretty much the same as you know it from glass and carbon fiber composites. You need to work really, really high end, so it's not a material for like a hand layup or something like that. Um, and right now it's still like a bit higher costs, but the rest is pretty much the same as you know it from glass and carbon fiber. So and yeah, the properties are like not from compared to a carbon fiber, because yeah, I think they won't be a material to like a natural fiber material where you can yeah, equivalent carbon fiber. There's still a lot of products where you should stick on the carbon fiber, but all parts that you're normally building, like from glass fiber and stuff like that, yeah, you can just replace that yeah, from like a replace it as a with a flex fiber or something like that. Yeah.
You said there were 6 different sort of epoxies which you were using.
Yes.
So what is the structure of it? What is it made of?
It's actually different type of plant oil, and there's still like epoxy resins, and with different properties. Like some are like for hand layup, some are for vacuum infusion, and yeah.
So are these? Can you buy these sort of epoxies?
Yeah, sure.
Okay.
There are some companies around.
Okay.
Yeah.
You mentioned the recycled bottle core material, but also cork. Are you using them for different projects, or is one better than the other?
Exactly. So you really need to decide what you want. Like if you use a cork, it's like higher weight and it's not as strong in the yeah, like pressure. Like it's strong because it goes in the old position back again. But when you really want to build like lightweight, you should, yeah, more use recycled plastic bottle as example, because you get like pretty much the same properties as a normal virgin PET foam.
Thank you.
So thanks for listening, and have a nice day.